Hello everyone, welcome to the YouTube channel Mission Net Physics Exam, and this is the video where we will be considering the another story about the atoms. So we will be talking about some of the very important points in this video today, and if you have not checked out the previous video, you can even check it out on the channel, that's Mission Net Physics Exam. So on YouTube channel Mission Net Physics Exam, you will be finding more other informative videos, and I hope they are gonna be helpful for you too. Now let's start today's story about the atoms. Actually, we are going to have a very active element in this story, or you can say a person in this story. Now who is that? So it's going to be electron. So now it's the entry of electrons in our story, okay? And this is going to be a particle or a person, you can consider anything, who is going to have so much energy, so can't sit at one place. In that case, it will just keep on moving around a circle, okay, or the main thing which is present at the center and having some chocolates there, okay. Now why chocolates are there and what is the role of those chocolates present at the center, I will be telling you one by one. So electron is going to have so much energy and can't sit at one place. So it will keep on moving in the circular orbits around the nucleus, and nucleus is that place where we will be having the chocolates. And the chocolates are responsible for the force who just let the electron move around the nucleus. And that force name which is acting on that electron is Coulomb attractive force, okay. So you can consider it this way, that electrons having so much energy, so they keep on moving around the nucleus in the circular orbits. Done. And the another thing here they need to, like, we need to know about, and which is letting them just move in that circular orbit. And since they are the naughty particles, okay, they can even go here and there, but why they are not going here and there? Because of the Coulomb, or you can say Coulombic attractive force, and it is due to the chocolates present at the center, as we are making the story by relating it with the daily life or some activities we generally observe. So that's why we have introduced the chocolates there, okay. Now let me know if in case there is something which is not getting clear to you in this story. So this was the first thing here we need to know about the story related to the atoms, okay. Now the next thing, what will happen next? So next thing is, we are going to talk about the electrons a little more in this story, because it's atoms story, but inside the atom there are electrons, there is nucleus. Done. So what is the role of electron and what electrons are doing, why they are just keep on moving in those circular orbits, that's what we have covered till now, and that's our first postulate of Bohr's atomic model we are going to consider here. Now the point is, this naughty electron, can it move anywhere, or is it just gonna move in some of the allowed circular orbits? So since it is gonna have a fear, okay, of other like other particles, other more heavy particles, you can say, or other persons, okay, so it will be just allowed, or it will be just able to move in some of the widely separated circular orbits, or you can say the permitted circular orbits. So it will not be moving randomly anywhere, it is gonna have some reason allotted to it, okay, and there are some circular tracks which have been allotted to it, and it will only be able to move in those circular tracks or the paths, okay, which are just the orbits, we call them orbits. Now when electron will be moving in one particular orbit or the circular path, since it's just doing the same thing regularly, so next we are going to consider that when it is moving in same circular orbit, okay, in that case what will happen? It will not be losing or radiating any energy, okay, same circular orbit, then it will not lose or radiate any energy, okay, not radiate any energy means it doesn't need more food, and if it needs food, it has to go somewhere, like that you can consider it. Okay, now in that case, what will happen next? When it is keep on moving in particular permitted orbits, okay, the circular orbits which have been separated by each other, so in that case those orbits have been given the name and we call them the stationary orbits. Okay, and that is one of the reasons that it's not radiating energy or not losing any kind of energy in that way. Okay, stationary orbits, so those orbits are known as stationary orbits. Now here there is one more point in this story you have to consider. What is that? That is going to be, if you will consider the angular momentum, okay, because it is just keep on rotating, it's moving in the circular orbit, so there will be what? There will be the concept of angular momentum. Angular momentum of what? Angular momentum of electron. So now the angular momentum of electron will be what? Will be the integral multiple of h cut. So which means L is equal to what? L is equal to R cross P. Everybody knows about it. Okay. And also we can write it as MVR. Done. MVR, because P is equal to MV. So we are also going to get it like the magnitude part as MVR. So if I will be talking about the nth state or nth orbit, the nth track or the path, then what I can write? I can write it as ME for electron's mass, Vn and Rn. R is the radius, okay, V is the velocity. Now in this case, what will happen? In this case, it is equal to NH cut because of the integral multiple of H cut. Now what will happen? You can simply find the values of radius, okay, where in which path it can move, where it is supposed to move the electron. And also if you will proceed further for more simplification, you know h cut is equal to h upon 2 pi. So simply you will be able to write it as 2 pi Rn is equal to NH upon MEVN, which is simply going to be N lambda. So this is what? N lambda. So here you are reaching to a conclusion. This is the circumference of the orbit or the circular orbits. Okay, which is what? It's going to be the integral multiple of the de Broglie wavelength, which is associated with the electron. Done. So that's how you have reached to the next point. Clear? And I hope till this point everything in this story is getting clear to everyone. But in case if you are going to have any questions or queries, let me know. So now here comes the next important point in this story, and which says that when there will be an electron which will be making some kind of transition. So till now we have talked about it, that there is a very active particle in the atom and that's going to be known as the electron, which moves in the circular orbit only because it is like having some of the things. You can consider chocolates are present at the center or something like that you can consider, but it's not actually the same thing. But the Coulombic attractive force is acting on it, and that's the reason it will just keep on moving in the circular tracks. The next thing is, when it is doing the same thing, then it is not losing any kind of energy or not radiating any energy. Such type of orbits in which it will keep on moving will be known as the stationary orbits. Such tracks are known as the stationary orbits. And there is a statement we are going to have regarding that when an electron will be moving in these stationary orbits, then in that case the angular momentum associated with the electron will be what? The integral multiple of h cut. From there we have got some important conclusions and the expressions. But here comes the next thing now. Maybe the electron will get bored while moving in one of the circular orbits and want to move somewhere else. Means it want to make some transition now, and it can be from the lower to higher energy or higher to lower energy. So if it is the case that it wants to move from higher energy to the lower energy, then in that case the emission of radiation will be taking place. If you have watched the previous video, okay, related to the story of atoms, you will be familiar with that thing too. So it is having the higher energy, it is having the lower energy. The electron wants to move from that orbit which is having the higher energy to the another orbit which is having the lower energy. Then it will have to radiate some energy. Okay. So in that case, it's just doing some work to go from one place to another place, and for that it is having the energy inside the electron itself, so it's just leaving that, just removing it, clear, emitting out that energy. So in that case, what will happen? This radiation which will take place will be equal to what? It's going to be the higher energy minus the lower energy is equal to h nu, or you can also write it as hc upon lambda. Okay, that's the relation between them. Now in this case, nu is the frequency of the radiation and lambda is the wavelength of emitted radiation. This is what you are going to have. Please let me know if in case there is any doubt you are going to have. So this is the case when electron wants to move from one energy level to the another energy level, then what will happen? So these were the postulates we had and the important points we are having regarding the electrons. Further, we will be doing more important discussion, and I hope each and everything is getting clear to you in a simple way. So let's keep it this much in this video today. I would even like to tell you something about the Unacademy subscription right now, and anytime if you are going to take the subscription, use and apply the referral code which is Anjali A Live. You can write everything in the capital letters, okay? Just apply the referral code and you will be getting the discount in the total subscription amount too. When you will be taking the Unacademy Plus or Unacademy Iconic subscription, what are the benefits you will be getting? All that has been shown here on the screen. Now for the Iconic subscription, what are the benefits you will be getting if you will take the Iconic subscription? They have been shown here as well. Another thing is free unit-wise PYQ tests are also available on the Unacademy learning app, so you can even check them out. Regarding the UA Lite subscription, we are having the information here on the screen. Regarding your upcoming exam, we are going to have the updates that can be in September itself. So get ready for your upcoming exam by preparing most important topics and more important questions with the YouTube channel Mission Net Physics Exam. If you are new on this channel, that is Mission Net Physics Exam, you can subscribe this channel by clicking on the subscribe button below this video. Thank you so much everyone for watching this video till the end. You can even share this video with your friends too. Let's keep it this much right now in the session, guys.